Hello everyone. So we will continue with the hypothesis testing, and today we will cover the last module, which is uh, to know how to analyze data and complete hypothesis testing. So in this session, we will go through to explain the suitable methods of analyzing data. Uh, then explain different data testing techniques, and explain how findings would be interpreted for the chosen testing technique. So the first one is to look into explain suitable methods of analyzing data. So data analysis is generally dependent on the type of data that is being collected, and it is aligned with the research objectives, like I said in the previous session. So it varies depending on the type of data and research objectives. So that is the core essence of data analysis. So here we explain the suitable methods for analyzing data along with the references for further reading. So the first one is quantitative data analysis. So quantitative data analysis is preferred for most of the research. If you go through academic research, almost 80% of academic research is done using quantitative data analysis techniques. So in this quantitative data analysis, you have the descriptive statistics, which is the measures of central tendency and measures of dispersion to summarize and describe the data. For example, if you're collecting demographic data with respect to the age group. So the mean could be 32 years of age, the median could be 31.5, the range could be 25 to 39. So basically you would want to give the descriptive statistics. Then you have the inferential statistics. So inferential statistics are generally used in statistical tests such as t-tests, ANOVA, regression analysis, and chi-square tests to test the hypothesis, assess the relationships, and determine the significance of the research findings. So inferential statistics is the main essence of quantitative analysis. So in qualitative data analysis, there are different ways in which you can carry out qualitative data analysis. First one is thematic analysis. So in thematic analysis, you need to identify, analyze, and report themes or pattern within qualitative data. So this method is widely used for narrative data. So when you collect data through interviews, so this thematic analysis is the most preferred choice. Then you have content analysis. So in content analysis, you systematically analyze textual or visual content to identify themes, categories, or trends. So for example, if you're seeing themes related to Halloween or Christmas in the social media posts, so that could be one of your theme. So in content analysis. And then, so a content analysis, it is often used for media or document analysis. Then you have grounded theory. So grounded theory is another form of qualitative data analysis wherein the researcher develops theories or conceptual frameworks based on the data. So it is particularly useful for exploring new or emerging phenomena. Then you have the narrative analysis. So here the narration of the participants or the person of interest is undertaken and analyzed to understand the structure, content, and the meaning conveyed by the participants. So that is narrative analysis. So in qualitative data analysis, you should remember these four types, which is thematic analysis, content analysis, grounded theory, and narrative analysis. And basically, thematic analysis is one of the most widely used qualitative data analysis technique. Then the third type of data analysis is mixed methods analysis. So here what happens is convergence analysis. So in convergence, generally the researcher combines quantitative and qualitative data to corroborate or complement the research findings. So if the data is analyzed predominantly by quantitative methods, then a qualitative method is also used as a complement to support the research findings of quantitative data. So this method explores how different data types converge or diverge. Then you have sequential analysis. So in this, the data analysis is carried out in a sequential manner, starting with one type of data, for example, quantitative, and then using the findings to inform the other type of analysis, which is the qualitative. So there is not much difference between sequential and convergence other than in sequential, a structured way is followed. Next, we look into the different testing techniques and data analysis techniques which are used in statistical tests. So the first one is the t-test. So a t-test is basically used to compare a means of two groups and determine if they are statistically significantly different, which means that if, for example, you have one group of population from Manchester, one group of population from Liverpool, and just to see whether how interested they are in cricket or football, or and whether the means of the two groups are different. So that is one example where you can use the t-test. So this is the different types of t-test may include independent sample t-test for comparing two independent groups and paired sample t-test for comparing related groups. So these are the different types of tests. And then example. So if you're testing, if there's a significant difference in exam scores between two teaching methods. So if one teaching method leads to higher scores as compared to the other teaching method, so that can be compared using a t-test. Then you have analysis of variance. So the analysis of variance is to compare means of three or more groups to determine at least one is significantly different from the others. So ANOVA can be for one independent variable or for two independent variables. For example, you can use ANOVA test to assess if there is a significant difference in test scores among students taught by different instructors. So that can be an analysis of variance. Then you have chi-square test. The chi-square test, the main purpose is to test the association between two categorical variables and determine if they are independent. So the different types of chi-square test include independence, chi-square goodness or fit test. An example could be investigating if there is a significant relationship between gender and voting preferences. For example, in US, if the male gender prefers Republican Party and the female gender prefers Democratic or something like that. Then regression analysis. So regression analysis is one of the most commonly used techniques in statistical analysis and in quantitative methods. So the purpose of regression analysis is to model the relationship between a dependent variables and two or more independent variables. So the different types of regression analysis include linear regression for linear relationship, logistic regression for binary outcomes, whether yes or no, and multiple regression for multiple predictors for a single dependent variable. So an example of regression analysis where actually regression analysis can be used is predicting the sales of a product based on advertising expenditure and product price. So these the sales of a product is the dependent variable, and advertising expenditure and product price are two independent variables. So here you can conduct a regression analysis. So next we have the correlation analysis. So the purpose is to measure the strength and direction of the linear relationship between two continuous variables. So an example could be examining the correlation between study hours and GPA score of the candidates. Then another statistical test is the Mann-Whitney U-test and Wilcoxon signed rank test. So this is a type of non-parametric test which is used when the assumptions of normality are violated. So remember in all the previous tests that we discussed, it is assumed that data follows a normal distribution. But When that is not the case, non-parametric tests are used, or when dealing with ordinal data. So Mann-Whitney U test, it compares two independent groups when the data does not follow a normal distribution. And Wilcoxon sign rank test is used to compare paired data from related groups. And then number 7 is Kruskal-Wallis test, which is also a non-parametric test. So remember, non-parametric test means data which does not follow normal distribution. So it is used an alternative for ANOVA, which is used for comparing 3 or more independent groups when the data is not normally distributed. So don't be like overwhelmed by the number of statistical tests. Remember, in quantitative, you should know correlation test, multiple regression test, and independent sample t-test. If you know these three, like that is good enough to guide you till your master's degree. Then we look into the non-parametric tests. So these tests are used when data does not meet the assumptions of normal distribution. So examples include chi-square goodness of fit test, Fisher's exact test, and the sign test. Next, we have the Mann-Kendall test, which is used to assess trends or monotonic patterns in time series data. Like, for example, we discussed in the last session, the GDP growth rate of a country. So that is a trend, then or inflation rate. So that is again a trend over the last 10 years, something like that. So time period you need to decide. So Mann-Kendall test is used for this purpose. Then we have McNamara's test, which is used to compare paired nominal data often in before and after studies. So now we look into how findings would be interpreted for a chosen testing technique. So interpreting the findings of a statistical testing technique is very crucial. So basically you have analyzed, you have generated a statistical output using, say, SPSS software. Now, what next? So next you have to interpret the results. What results have you observed? How is it consistent with the existing academic literature and something of that sort? So the first step is state the null hypothesis and alternative hypothesis. So the null hypothesis we studied in our last session. So this is the default assumption that there is no significant difference between the two groups being compared. So that is how you formulate the null hypothesis. Alternate hypothesis is this is the hypothesis you want to test, suggesting that there is a significant difference between the two groups. For example, there is no impact of advertising expenditure on brand visibility. So that is the null hypothesis. But when you test the results and the results are statistically significant, then there is an impact of advertising revenues on brand visibility. So that is how you formulate the null hypothesis and alternate hypothesis. Next, step 2 is calculate the test statistic and p-value. So you perform the t-test using your data to calculate the test statistic. So it quantifies the difference between the sample means. So and the third step is setting the significance level, which is the alpha. So the alpha is set at 0.05 or 5%. So any statistically significant results will have to show less than 0.05. So this represents the threshold for statistical significance. And then the fourth step is to interpret the p-value. So if the p-value is less than or equal to alpha, the null hypothesis is rejected. So which indicates that there is a sufficient evidence to conclude that there is a statistically significant difference between the two groups. So that is how you reject the null hypothesis and accept the alternate hypothesis. Then if the p-value is greater than 0.05 threshold level, then we fail to reject the null hypothesis. So this suggests that there is not enough evidence to conclude a significant difference exists between the two groups. Then the test statistic is also interpreted, which means if the null hypothesis is rejected, you need to examine the sign of test statistic, which indicates the direction of difference. For example, if the uh, results obtained for a correlation test are statistically significant, and you see a positive association, which means that the dependent variable and the independent variable relationship is positive. That means impact on one also impacts the other. So that is how you interpret the test statistic. Then providing the practical interpretation. So beyond statistical significance, you need to provide a practical interpretation of the research findings. So what does the difference mean in the context of your research question? Is it practically significant, or is it a merely a statistical artifact? So what it means that you need to relate your statistical findings to your research objectives and research questions, and whether it agrees with the uh, existing academic literature. And finally, you need to consider the limitations. You need to acknowledge any limitations or assumptions associated with the test. So this is, for example, if you have collected a sample of only 75 people, so you need to accept the limitation that an ideal sample is 200, but due to lack of time, only 75 sample size was collected. And then step 8 is to conclude the result, which is to summarize the interpretation by clearly stating whether the null hypothesis was rejected or not, and what this implies in terms of your research question. So here we also provide an example for a t-test. So based on the results of the independent sample t-test with a significance level of 0.05, we reject the null hypothesis H0. So this indicates that there is a statistically significant difference in the mean scores between group A, M is equal to 78.5, and group B, M is equal to 85.2, with T statistics is equal to minus 2.56 and P is equal to 0.012. So the negative sign in the T value suggests that group B has a significantly higher mean score than group A. So in practical terms, it suggests that teaching method used in group B may lead to better learning outcomes as compared to group A. Now we look into the merit criteria for this learning outcome. So this is suggests situations where different testing techniques may be relevant. So here again, we list out the different situations where the different statistical techniques may be used. The first one is t-test. So if you want to determine if there is a significant difference in the mean income between two groups, group A and group B. So group A consists of males and group B consists of females. So that is one t-test scenario. Then you have ANOVA, which is analysis of variance. So here you are investigating the impact of three teaching methods, method 1, method 2, and method 3 on student exam scores. So you want to know if there is a significant difference in mean exam scores among the three methods. Third is chi-square test. So in chi-square test, the scenario could be you're studying the association between the smoking status, whether a person is a smoker or non-smoker, and the occurrence of lung cancer, yes or no, in a large population. So you want to determine if there is a significant relationship between smoking and lung cancer. Then you have a regression analysis. So here the scenario could be that you are interested in understanding the factors influencing job satisfaction. So you collect data on variables such as salary, working hours, and job role, and want to model how these factors predict job satisfaction. Then you have correlation analysis. So here the scenario is that you're examining the relationship between the amount of time spent on social media and academic performance among college students. So here you want to measure the strength and direction of this relationship. Then for Mann-Whitney U test and Wilcoxon signed rank test, the scenario is you are comparing the median income of two groups, group X and group Y. However, the income data is not normally distributed and you have ordinal data. Then you have the Kruskal-Wallis test. Here the scenario is you're investigating the effect of 3 different brands of a new energy drink on energy levels, which is measured on an ordinary scale, low, medium, and high. And you want to know if there is a significant energy levels among the 3 brands. Then you have the non-parametric test scenario where you are comparing the distribution of customer satisfaction ratings, which is ordinal data, and for 2 different customer service methods, which is method A and method B. So this data does not meet the assumptions of parametric tests. Then you have the Mann-Kendall test. Here you're analyzing time series data of monthly temperature measurements to detect any significant trends or changes in temperatures over the years. So Mann-Kendall test is widely used for climate change reporting tests. Then you have the McNamara's test, where the scenario is that you are conducting a before and after study to assess whether a new medication has a significant impact on symptom improvement, which is yes or no in patients. So next we look into the different testing techniques used in different situations. So here again, we use the different tests such as t-test, we have the ANOVA, we have the chi-square test. So we already discussed these in detail earlier. Then you have the scenario and the justification, the regression analysis, the correlation analysis we have. You have the Mann-Whitney U-test and Wilcoxon. So here the justification could be these non-parametric tests are useful when dealing with non-normally distributed data or ordinal data. Then you have a Kruskal-Wallis test. You have the non-parametric tests. And finally, the Mann-Kendall test and McNamara's test. So in McNamara's test, the before and after assessment could be comparing paired normal data. So it is suitable when assessing the impact of a new treatment or intervention on a binary outcome like symptom improvement in patients. So the second distinction criteria is to assess the implications of different interpretation of test results. So interpreting test results is a crucial step in research, like we've already highlighted in our previous sessions. And it also influences the decision making and basically how you have presented the data and what is the outcome that you are getting. So different interpretation of test results can lead to varying conclusions and implications for research. So the implications of different interpretations could be scenario. So the first scenario could be comparing 2 teaching methods. So here you consider a scenario where you are comparing the effectiveness of 2 teaching methods, method A and method B, on student exam scores using a t-test. So the interpretation is the null hypothesis. You reject the null hypothesis. That is, if you interpret the results as statistically significant, you conclude that there is no statistically significant difference in mean exam scores between method A and method B. That means both are same. And you may recommend adopting more effective technique, teaching technique based on statistical evidence. And interpretation 2 is failing to reject the null hypothesis, which is if you interpret the results as non-significant, you conclude that there is no statistically significant difference between method A and method B. And the decision may be, you may decide that there is insufficient evidence to favor either method A or method B. Now, the implications of different interpretations is resource allocation. For example, rejecting null hypothesis. So resources may be allocated to implement more effective teaching method, which is method B. Interpretation 2 is that status quo may continue, wherein resources may not be redirected. Then educational policies. So in interpretation 1, where method B is more effective, educational policies may be influenced to promote the adoption of method B. Then interpretation 2 is that policies may remain unchanged with respect to the 2 teaching techniques. And third is student outcomes. So the interpretation is that if method B is more effective, students taught using this method may have better outcomes. And in interpretation 2, student outcomes may not significantly differ between the two methods. So these are the interpretations and implications of the different statistical techniques. And then further research. So additional research may explore why method B is more effective and how it can be optimized. And if you fail to reject the null hypothesis, further research may be needed to identify other factors influencing student performance. Then in terms of educational investments, uh, educational, educational institutions may invest in training educators in method B. And in interpretation 2, investments in educator training may not be prioritized. And finally, in long-term impact, the interpretation 1 for null hypothesis being rejected is that it may include improved student achievement and educational outcomes, whereas in interpretation 2, the long-term impact may remain uncertain due to lack of evidence supporting method B. So that is all for today's session. In case if you have any questions, you can let me know.